Hello and welcome to the fourth and final session for the A2 series of chemistry in spring 2024 before, of course, that live session will take place next week. So for those of you that are already familiar with Karen Cymru, it's likely you already know me, but for those of you that aren't familiar with me, my name is Nera Stevens and I'm a chemistry teacher in Ysgol Bro Pedyr. So as I said, this is the fourth session of the spring 2024 season. You can see there the titles of the three previous sessions, which you may well have already tuned in for. But if not, it is well worth possibly going back and looking at those three sessions there. But as outlined there, my session today will outline an approach to Unit 5 assessment, all of which you will face in this summer. Okay. So just going to bring to your attention something that I would say is an invaluable resource, and a resource I'm hoping that you're all already highly familiar with, which is experiments on film. Now, it's a resource that has focused on the core and compulsory practical that are specified by the WJC themselves. It is intended to help you as pupils to kind of strengthen your confidence and strengthen your practical skills, of course. And it is an invaluable resource in completing that laboratory book that you've been working on for the past 18 months, etc. So yes, whilst it was intended originally to be more of an independent resource, it is very, very commonly by us teachers, me included, to use it within our own lessons as well, just to strengthen and develop and support you as pupils as you go through the practical elements, both in AS and in A2. So I put on that slide there a link to the website that will take you directly to the chemistry practicals. And hopefully that if you aren't already familiar with it, then it will be a useful resource that you can then explore over the coming months leading up to your Unit 5 assessment. So Unit 5, during the 18 months which you've been studying chemistry, you should have picked up quite an array of skills, really. So I'm just going to quickly go through the kind of skills with you. The expectation is that you are very confident and able by now to do the following. So methods of data collection and analysis. I'm not going to go through it and read it for you. You can pause and do that at your leisure. But certainly, if there are any of those bullet points there that you feel that you aren't 100% confident with, then certainly either accessing the experiments and film I previously mentioned, or just to have a chat with your own teachers within your schools or colleges, and make sure that you are fully confident, because any of these skills could be questioned and could be assessed, therefore, in that Unit 5 assessment that you will face in May. So risk assessment, the second thing there, it kind of built upon what you did in GCSE, really, which is that you are meant to be familiar and confident in highlighting any hazards within an experiment that you will carry out, be able to identify any significant risk within the method, and also then, of course, have a reasonable and sensible control measure in order to limit that risk. Okay, so as it says there, the hazard is the object of the chemical. Don't forget to mention the nature of that hazard there, so whether it's corrosive, etc. The risk then is a specific action. Now that is, if you look at your laboratory book, is what point within that method that you are following will it or could it potentially create a risk for you from any of the hazard that you previously mentioned within the risk assessment. And then the control measure, don't forget that it has to be practicable. So it has to be sensible, has to be realistic, and be reasonable within the context of the practical that you're carrying out. Table of results, of course, don't forget to present numerical data in single clear table of results. Okay. Your column heading should be the only place where you see your units, etc. I don't mean to go over things that you may already know and familiar with. It's just important that these little details are there, because these are the differences between gaining a mark or not gaining a mark within that first paper you'll sit, which is the practical element itself, of course. So in columns, okay, don't forget that you need column for all the primary data. and then you calculate any values from that data in its own column, of course. This is something that has risen its head with my own pupils over the years, and it's something that I keep reminding them of. That last bullet point there, it is really important that you have your own data to the same number of decimal places as the apparatus resolution. So if you're using a burette, for example, in a titration, if the volume, of course, of the burette is measured to the nearest 0.05 centimeters cubed, then all your volumes in that column should also be recorded to the nearest 0.05 centimeters cubed, including your average or your mean value. Okay, and make sure that it is consistent throughout that table. Recording results in significant figures then links very closely to what I've just mentioned there, really, is that you have to be very, very conscious that you are giving and recording your results to the resolution of the apparatus that you're using at that given time. Okay. And it should be consistent within a column of data. So even if what happens very commonly is that somebody may have a titration, for example, that's exactly 20 centimeter cubed, they might well be tempted to note it as 20, but it has to, of course, be noted as 20.00. And that, again, may possibly be the difference between a mark or not. The graphs then, no great kind of complexity from what you did in GCSE and possibly earlier there, but just don't forget to look at them. Read through these points. These I'm not going to go through with you. Pause if you're going to have a quick read of them. But I will mention the requirement at times for false origins. And don't forget that that is actually very acceptable. So it may be sensible and in fact result in a better graph if you remember the need for a false origin at times. Estimating uncertainties, this is something else that is frequently asked within the first Unit 5 paper. So once you've done your experiment, which I'll take you through in a minute, you will be required to estimate uncertainties or very likely be asked to calculate uncertainties. Draw conclusions and valuations, of course, so no point doing an experiment if you do not conclude something or learn something from that, and then you, of course, need to evaluate your processes and your data potentially. So these are all familiar to you. I'm hoping that you've done very much the left-hand column there. So of course those are primarily based on your year 12 work. And the top few there are from Unit 3, which you're likely to have covered already, but if not, you certainly will do over the next few months. And if any of those have not been carried out due to apparatus limitations in your school or that you were absent, please make sure that you are confident in at least knowing how you would have tackled the write-up to those experiments, regardless of whether you've done it yourself or not. Okay, and again, that experiments on film could be beneficial and be really useful in helping you fill any gaps that you may have in your laboratory book. So Unit 5, the whole purpose of the session, it is designed to ultimately just test your hands-on practical skills, really, and whether or not you are able to analyse results and draw sensible conclusions based on the observations that you make during those experiments. Now, it does unfortunately still require, despite being a practical exam, it does require a great deal of recalled knowledge, and I'm sorry to do that. Maybe you weren't aware of that, but it's very, very true that even though it's a practical one, you will very much still need to know quite a vast amount of information from all your practicals, but also on the theoretical units and topics that you've done, both in year 12 and in year 13. So I'm sure you're already familiar with it, but if not, then you are likely facing your first Unit 5 experimental task, then the actual real practical, as my pupils would call it. That takes place this year on the 8th, or if you're in a large centre, it might overflow into the 9th of May. And then the practical analysis, the written practical paper, will take place on the morning of the 10th of May this year. Now, you work independently and individually on both those assessments. There will be no group work element that will creep into those. You are doing it on your own and you will have to write them up on your own as well. Okay, so to do with the experiment task itself, you get 3 hours to complete the experimental task. It takes place in two parts. There will be two elements, there's two separate things to carry out, and you collect both the results before you then move on to the analysis part of that paper. And then 2 days later, or a day later in the case of some of you, you'll then face an hour written paper. All the questions on this paper will be based upon practical work that you've hopefully carried out yourself or have at least observed your teacher or within a group somebody carrying out. As mentioned, it does require a good deal of recalled knowledge, unfortunately, and certainly there will be a requirement to carry out calculations on either one or potentially both parts of that practical task that you carry on. And then in this paper, there's likely to be at least one calculation as well. So what I'm going to do now is just take you through some of that recall work that will benefit you to have in the back of your minds. I'm not saying that I can cover all of it, because obviously during year 12 and year 13, you've covered quite a heavy amount of content, but I will maybe focus in on some of the most important aspects, starting with organic functional group tests, of course. Okay, so through your study of work in units 2 and 4, which were heavily organic, as you recall, you've already discovered that there are reactions that are specifically used, tests that are specifically used to identify functionality. Okay, so for example, building on GCSE, I suppose you know that bromine water is a test used to test for unsaturation, so it identifies alkenes. Again, kind of based primarily and built upon in year 12 onwards, is that you know that the halogenoalkanes can be identified by carrying out a few steps, but then ultimately the final test being that silver nitrate producing a precipitate of a certain colour. All of these tests, I won't go through every single one of them, but please be aware there are a few other reactions as well that can be used as chemical tests for these functional groups. But knowing a test for each functional group or each family that you've come across is pretty sensible, I would say. So as I said there, the test for the alkenes or tests for unsaturation, of course, is the use of bromine water. And that results in the orange colour becoming decolorized. Okay, so chemical test for an alkene, simply add that bromine water and the orange to clear, colourless. Okay, I will say that this is something that I am guilty of myself sometimes. So I tend to focus and emphasize it to my pupils. There is a vast difference between clear and colourless, okay? And in the test for unsaturation, the orange becomes both clear and colourless. But I would say out of the two, the focus needs to be the orange to colourless, okay? If you say orange to clear, you will not get that credit, okay? Test for halogenoalkanes then. Well, testing for a halide ion, obviously inorganically, which you came across in GCSE, is a bit more straightforward and requires less steps. Okay, but ultimately it takes place by first and initially adding sodium hydroxide, of course, which carries out that nucleophilic substitution. Okay, and then that will liberate or release the halide ion to be free from the carbon chain. You then acidify it with nitric acid. You then add the expected reagent, which is silver nitrate, and look for a precipitate that's likely to be white, cream, or yellow if a halide is indeed present. Carboxylic acid, again, something that touched upon in GCSE, but certainly not left behind and has been recalled once again, is that second one there, which is that you know that carboxylic acids, as is the case for most acids, they will react with a carbonate to liberate carbon dioxide. Now, the first one there, you may be less familiar with, but I'm hoping that you understand that carboxylic acids react with sodium metal as well, as do alcohols, okay, to liberate the hydrogen gas there as well, okay? So kind of acting upon that reaction of an acid, adding an acid to a metal will give you a salt and hydrogen gas. Now, the chemical test for carboxylic acid, sensibly then, because of the fact that some of them give a positive for more than one class, it's probably best to stick to that second one there, which is the addition of a carbonate. because sodium carbonate added to a carboxylic acid will liberate CO2 gas, and not all alcohols will, of course. Okay, you then, to confirm, maybe as a final confirmatory test, simply bubble it through lime water, and you will get that white precipitation of calcium carbonate, so it goes cloudy, of course. Now, all alcohols, as well as carboxylic acids, react with sodium metal. Okay. So if it is positive for the test for sodium, but negative for the sodium carbonate, then you know that you're looking at an alcohol. Okay. You could also rely on identifying an alcohol through the oxidation reaction of it. Okay, so we know that we've got the oxidizing agent, potassium dichromate, or in some cases you might have been using potassium manganate 7, of course. But in this case, if you use the potassium dichromate, it goes from orange to green. Now, it's a reaction that I encourage my pupils to think of a bit like traffic lights, really, where it goes from orange to green. Just a way to trigger your minds, maybe, to remember which one is which, because it would be a shame if you got the color change in reverse. So think of it as traffic lights, goes from orange on to green. As you can see there, primary and secondary alcohols will indeed be oxidized, unlike tertiary ones, which will remain orange because oxidation is not possible by the use of dichromate. So summary, the pathways there. We know that the primary alcohol will create an aldehyde onto an acid, and then alcohol secondary will end up being a ketone, and then of course the tertiary alcohol will not be oxidized. So based upon that, the chemical test for alcohols, first add the sodium. It will fizz with all the alcohols, primary, secondary and tertiary. If you add potassium dichromate or acidified dichromate in the presence of heat as well, so you usually reflux it, these primary and secondary will then continue on to the green coloration. Doesn't help you if you want to differentiate between the primary and the secondary, of course. So you'd need a second test for that, and I would suggest the test for an aldehyde here. Okay, so if you test for an aldehyde, there are two common ones that will be acceptable. Okay, so the first one there is tolerance. So you have silver ions that will form solid silver, precipitating out when it's present in ammonia. Okay, the other one that could well be used is failings, a bit similar to the Benedict's colour that you'd come across in biology if some of you do biology as well. So you'd have the blue colour creating that red or brick red coloration. So aldehydes can oxidize further to carboxylic acids as well. So if you are also wanting to differentiate between primary and secondary and you're uncertain, and you've got no availability for tolerance, you could try just oxidizing both and then testing the products with the sodium carbonate, of course, because that will give a positive for primary and a negative for the secondary alcohol. Okay. So let's see if you've got an understanding of just that quickly. So just a very brief stop there for knowledge check. At this point, I would suggest that you do indeed pause this video and have a look at the data and maybe yourself try identifying which ones are which. So compound A to F are one of the following, you just don't know which one. So analysis of that data and those results should enable you to identify which one's which, of course. So maybe pause at this point, and then when you're confident you have identified A to G as each of those compounds, then unpause and then check whether you're correct. So hopefully you approached it in a sensible manner. So I would always say the first thing I would encourage my pupils to do is identify which of these tests along the top will help you identify which functionality. Okay, and a second step I would really highly suggest, so it's a very good tip, is it is always sensible to start with a column of observations that only gives you one positive, of course, because that will eliminate it in a shorter amount of time. And that is another important skill that they expect you to pick up, is that they'd expect you to be able to identify things in as few steps as possible. So in this case, if you focus on this column here, The bromine water being added only has one positive result there, and we know that the bromine water is used for the identity of unsaturation, so that automatically tells you that B must be an alkene. Okay, again, focus on this column here. You've got the silver mirror, which is, of course, an identity step for aldehydes. And again, we can see that there's only one positive, and that means we've confirmed that A must be the aldehyde. This only got one positive result, and also, if you recall, sodium carbonate will create effervescence or fizzing with the carboxylic acid. So we can see there that D must therefore be the carboxylic acid. Now, last one with only a single result here is that we have got a addition of the NaOH to nucleophilically substitute that, acidified with nitric acid and then followed by that silver nitrate, gives you a white precipitate. So that column there is the identity steps for a halogenoalkane, of course. So we know that G must be the halogenoalkane. Not only do we know it's a halogenoalkane, but the fact that it is a white precipitate also confirms that it must be a chloro compound. Not only a halogenoalkane, but a chlorohalogenoalkane. So you're left then, so we've identified the carboxylic acid, we've identified the alkene, we've identified the halogenoalkane, and we've identified the aldehyde. So we are then left with a choice of a ketone, a primary and a secondary alcohol. So which one is which? Okay, well, if you look at the sodium being added, then we know that that then is possible for primary, secondary alcohols, as well as the carboxylic acid. We've identified that already. So if you continue by process of elimination, and the fact that we've got oxidation here and oxidation here, okay, means that it can't be the ketone. So by process of elimination, the only one that fizzed but did not give, so we're looking at this column, okay, it did not get oxidized, is that we know then that the ketone has been identified. And then you are looking at differentiation between a primary and a secondary alcohol. And we know, therefore, that we have those as the only possible solutions to that problem. So hopefully you got that right. And if not, then maybe take a look back at the positive expected results for the different classes. Now, as I said, I can't cover everything in one go. This session is only 40 to 45 minutes long, ideally. So what I have put there is 2 further links that I would really strongly suggest that you explore at your leisure. There are 2 websites that my own pupils use regularly, which is, and I'm sure you have come across them as well, so physicsandmathstutor.com, as well as Quizlet. Now that one at the top is primarily for the organic ones, as you can see there, but this one is tests for functional groups as a whole. Okay, so it brings in a bit of the organic as well as the inorganic compounds as well. So talking of inorganic, I'm going to go and quickly do that. Covered again, somewhat built upon your GCSEs. So recall from GCSEs that you're already familiar with flame tests and the expected colours of certain cations, as well as the precipitate test that you did later on in year 11 of GCSE as well, but covered since then. Be confident that you know exactly how to carry out the flame test and why each step is required. Things like why is nichrome used, etc. Why is the blue flame used? So be confident that you can answer such questions. Now, these are the flame colours. Now, they are quite particular at times that you are clear about the scarlet versus crimson versus brick red, etc. So you can't say red. They would like you, please, to state the shade of red. But in particular, this is one that they're really not forgiving on, is that if you say that calcium is red, it tends to be brick red or orange red that they would credit in an exam, okay? Precipitate, as you know, you add the many tests for anions and cations are precipitation reactions. So the metal ion combined with the hydroxide ions, then either sodium hydroxide solution or ammonia solution, they form insoluble precipitates. So I won't dwell too much, but there are, just to recap there for you, summary of certain cations and how they would precipitate out with certain compounds. Okay. And then identifying anions and cations. Now, lots of these are quite straightforward ones in reality. Okay. And again, there is a resource link there for you. It is prepared by the Royal Society of Chemistry. They're extremely good at providing support materials for all age students, really, but in particular A level. And don't forget that as an A level pupil, you are entitled for free membership. So please, if you haven't already done so, go on their website. They've got a wealth of support material there for you. But simple test tube reactions are often used, and they're straightforward, quick and easy to carry out, but they will enable you to identify quite an array of anionic and cationic species, from group 2 ions there all the way down to sulfate, carbonate, etc., that I've touched upon already. So if the sample to be tested, don't forget though, is a solid, then you must be aware that it needs to be dissolved in deionized water and made into an aqueous solution initially. Okay, if it's insoluble in water, then there are other solvents available, but tends to be the suggestion is try dissolving it into an aqueous solution first. So test for group 2 metals. Okay, I'm not going to go through the method with you, but feel free, if you're not confident with that one, pause and have a read of the suggested method. But these are the kind of results that you'd see. So you've got the magnesium, calcium, strontium and barium there, giving an array of precipitates. Test for ammonium ions itself. Now, ammonium ions, as you learnt in GCSE, but certainly touched upon since, is that if you add sodium hydroxide to it, it will give off or give the evolution of ammonia gas. And then you must be confident in recalling how you test for that ammonia gas, of course. Okay, which is the use of damp red litmus that will then be turned blue because of the basic nature of it as a gas. So test for halide ions. The halide ions in inorganic compounds is much more straightforward, but is the same final step, of course, as there would have been for the organic halogenoalkanes test. But in this case, the sample being tested is simply added to a test tube, acidified with nitric acid. Don't forget the importance of using nitric acid as opposed to something like hydrochloric, because of course hydrochloric acid may well give you a false positive if you use it. And then you're looking for the precipitation to be white, cream or yellow, of course. Okay, so the white precipitate, as I'm hoping you're aware, would be silver chloride, AgCl, which is insoluble. The cream one, silver bromide, and the yellow one would be silver iodide, of course. Now, what you've also hopefully built upon on your knowledge since GCSE is the fact that you can test and confirm the identity of that precipitate by using ammonia as well, because we hopefully have got you all familiar now with the fact that silver chloride will form a soluble complex even with dilute ammonia, while silver bromide will require the presence of concentrated ammonia, but then will indeed form a soluble complex, whereas the final one there, silver iodide, does not form a soluble complex with ammonia regardless of concentration. So if you have a yellow precipitate, of course, and you're unsure whether it's exclusively an iodo compound or it may have other halides presence, then the use of that final test there of ammonia is quite a positive step to take, because you can then eliminate the earlier precipitates, which is the silver chloride and silver bromide, because those colours may well be masked by the yellow coloration of silver iodide. So you can use that as a confirmatory test. So hydroxide ions, touched upon already, okay, but we know that sodium hydroxide is basic, so we'll turn red litmus paper the expected colour, of course, as will the universal indicator. Carbonate, very much tested in GCSE, but again has been built upon. So you would add the acid and you'd expect the evolution of CO2 gas, which, as we know, will turn lime water milky or cloudy. Now, I'm sure I don't need to emphasize that, but I'll be very, very clear that the only 2 allowed words are milky or cloudy for lime water's positive test. Sulfate, so you simply acidify the sample with hydrochloric acid and then add a few drops of aqueous barium chloride. And if you do have a sulfate present, then you'll get that white precipitate, as you can see happening in that test tube there. So what I've done, I've just dug out a few past paper questions. I've gone back a good few years because you may be aware of it, you may not be aware of it. But originally, a good, I think, probably over a decade ago, certainly, there used to be a written paper that tested practical skills both in year 12 and in year 13. I think, remembering back, it was coded CH3 and CH6. So based on that, what I've done is focus on the use of those questions, because obviously you've got the most recent Unit 5 papers that you can access independently yourself via the WJC website. So what I've done, I have just made the decision of going more historic and go to questions that aren't available to you over that kind of WJC website because it's too historic, it's too old, but they're still really worthwhile questions, I promise you. Okay, so first one there, and it's not dissimilar to the type of questions that you may well see in the second paper, the analysis paper in May. Okay, is that they'll give you a series of information and may either ask you to analyze the data or the results or explain the purpose of certain steps. So what you can see there is that you've got a method to use an experiment to find the concentration of chloride ions in aqueous solution. Okay, no further halide ions were present, and they took you through the different steps. So in each step there, they may well ask you what was the purpose of doing this, why they're doing this in this order, etc. Okay, so I've got the instructions there for you, slightly shrunk from the original, but nonetheless, you should be able to see it hopefully quite clearly. And the questions led you through the certain steps and why they were as they were. Okay. So as you can see there, the first question was write an ionic equation. Now, I haven't touched upon it until now, but I'm hoping you're all familiar with the different types of representation. So symbol equations versus ionic equations. If they specifically ask you for an ionic equation, the most crucial thing is the inclusion of state symbols. Without that state symbol, you're unlikely to gain credit. Okay. So if it is, as it outlines there in the first slide, a test for a chloride concentration, and you're using silver nitrate, the expected precipitate will therefore be silver chloride. So for the ionic equation, then what they'd expect you to do is highlight silver, but please state it as aqueous. Okay, it will combine with chloride, which is again initially an aqueous solution, not precipitated out, but when mixed, they will create the precipitate PPT, okay, of AgCl. And you must show your understanding of the fact that it would be a precipitation by using that state symbol solid. It then went on and asked you, which again is well within the remit of what they may ask you, is explain why certain things were done. So give a reason for using a slight excess of silver nitrate. Okay, well, the reason that you add an excess of silver nitrate is because you want to make sure that all that chloride is indeed precipitated out. So it's just a checking mechanism. If you've got the excess of the silver, then you know that it will precipitate all of that silver chloride out, and therefore there are no further ions present. So you've precipitated all the chloride out. That's the reason for going excess. Okay, why would you acidify the solution? Well, the main purpose of acidifying it is to make sure that you have no other silver products, really. So it's to stop any further silver salts being precipitated out. That's the purpose of acidifying it. It then went on to ask you further questions on the method and the logic of certain steps. So why would they test a filtrate with a little silver nitrate? So they moved on further into the method now, and they're on to the third bullet point there. So once it was precipitated, the filtrate then was tested with a few further drops of silver nitrate solution. Again, it is more than anything just a checking mechanism. It is a way of making sure you've got all those chloride ions precipitated out. If there are any remaining, then you will see clouding on addition. So you'll see that it will precipitate slightly on addition. Okay. Why do you wash the precipitate with water? Well, as is the case in most reactions, you will have some impurities present, and the purpose of washing then is to make sure that you're getting rid of any soluble impurities at that point. So by washing it with water, any soluble impurities will be washed away from that precipitate, leaving it in a more pure state. Why would you heat the precipitate to constant mass? Well, the purpose was, if you remember correctly, was to identify the concentration of halide ions, and therefore it is very important that you have just the silver chloride present. And for that reason, you need to make sure all the water is removed. So you heat it to constant mass, because you are then confident at that point that there is no further water. It's not damp anymore. Okay. And then we lead on to the maths. Okay, use the AR values for silver and chlorine as specified there to calculate the concentration of chloride in the original solution. If you remember, they specified that the mass of the precipitate obtained was 0.5 grams. Okay, and they simply then went on to say, right, fine, what is the concentration, therefore, in the original solution in grams per decimeter cubed? Okay. But the first thing to do for this one is, if you think about the fact that in 0.5 grams, how much chlorine was that, or chloride then, okay? So the mass of chloride, in this case, would be 0.500 times 35.5 divided by the molecular mass of silver chloride itself, of course, which add up 108 and 35.5 will give you a mass of 143.5. Gives you an answer then of 0.124 grams. Well, that's how much chloride there was in the 25 centimeter cubed sample, of course. Now it asks you for it in grams per decimeter cube. So if you think about it, the scaling factor in this case would be 40. So, of course, it's 40 because there are 40 25 mLs in a decimeter. So in that case, you had to scale up by a factor of 40, which gave you then 0.124 times 40, gives you an answer of 4.94 grams per decimeter cubed. Okay. Pen isn't behaving today, unfortunately. Right. So the moles per decimeter cubed, of course, then, well, if that's how many grams there are, and we know from the information supplied that chlorine has an atomic mass of 35.5, then to convert grams per decimeter cubed into moles per decimeter cubed, then you simply go 4.94 divided by 35.5, giving you then an answer of 0.138 moles per decimeter cubed. And this is possibly a good opportunity to remind you of something that you are very familiar with, I'm sure. But unless specified, they do like your mathematical or calculation answers to be given to 3 significant figures. Okay, and be clear that is significant figures, not decimal places. So 3 significant figures is what they are looking for. Now, if I went through any of that too quickly for you, then the mark scheme is on that slide there, as will be the case for all the questions I will go through with you. Okay, so it says there, the next question, you've got a sequence of organic reactions that's shown below. You've got A, B, C, and D. And then they're asking you for each of those organic compounds that can be identified using certain tests, which one will give a positive and what will that positive observation look like. As you can see there, A, B, C, and D Each of them will be identified with one of those 4 tests. You need to identify A, B, C, D according to the positive test and what that positive test would be. Okay. So first thing to do is go through your A, B, C, D. What are we looking at? Well, that's the halogenoalkane there. So we're looking for a test for halogenoalkane. The functionality in B is the unsaturated double bond there. So it's an alkene. That is an alcohol. And that is an acid. So once you've identified the functionality of the unknown compounds A, B, C, and D, then it is simply a case of spot the test for this right family. Okay, so in this case, this here is clearly a test for halogenoalkane, so that would be identifying A then, and you'd expect, because it is a bromo, you'd expect a cream PPT. Okay. This here, sodium hydrogen carbonate, is a test for an acid, so that would identify D, and you'd expect effervescence or fizzing of CO2. I'm going to put fizzing down because I was honest with you, spelling of effervescence always gets the better of me. So fizzing and CO2 given off. You could well then beef that up by saying that that can be confirmed by using lime water, which then become cloudy. Bromine water we know is a test for unsaturation, so we're then identifying B, and the test would be that it goes from orange. Do not be tempted by that clear. Orange becomes colourless. Okay. And then you've got only one left by process elimination, but also the fact that we know that we've got dichromate, which is an oxidizing agent. So we're looking for something that can be oxidized, and the only one there that can be oxidized would be the alcohol. So we're looking at C. And traffic lights, if you remember my tip earlier, is that we're looking for a color change from orange to become green, as traffic lights do. Okay. As I said, the answer's there for you as well, but hopefully you got that right. I'm going to go through, I think we've got enough time for one more. So let's go through this one. So you've got Egyptian mummies that have survived in a good state of preservation for thousands of years. The body of the mummy is treated with the mineral natron, a form of calcium carbonate. Now, this raised the pH of the body fluids to 11 and reduced bacterial decay as a result of that. So give a balanced equation for the reaction that occurs and any observations when aqueous sodium carbonate is added to aqueous calcium chloride. Now, they kind of tried giving you a hint there by including the word aqueous numerous times. So you didn't even have to remember that group 2 halides are soluble, so calcium chloride. We know that all sodium salts are soluble anyway, being group 1. The calcium being group 2 obviously has that differing solubility. So that's possibly another point to just stop and pause and think, are you confident in identifying the trends in solubility of group 2? So the carbonates versus the sulfates versus the hydroxide trends within group 2. Okay, because that's another common kind of factor that creeps into unit 5 sometimes. Okay, so we've got sodium carbonate reacting with calcium chloride. So the equation hopefully should be well within your ability. So you've got sodium carbonate there, you've got calcium chloride, a bit like a dance, they go in and swap their partners. So we get NaCl, 2 of them, and you get CaCO3. But you've created an insoluble carbonate now, because as we know, group 2 carbonates are insoluble. So you would expect, therefore, to get a white PPT created, because all group 2 salts are white, of course. Okay, but be clear that it is that calcium carbonate that's giving that white PPT result. Right. Use the equation to explain why the carbonate anion is acting as a base. Well, this is just quick checking with you that you're confident that you know the definition of an acid and a base. So acid is a proton donor, base is a proton acceptor, of course. Well, you can see there that the carbonate here has accepted a proton to become hydrogen carbonate there, so it is acting as a base, having accepted that. It then went on to ask you to calculate the concentration of hydroxide ions, so that required you to recall really two equations. So pH, as we know, is the minus log of H plus ions. And hopefully you are also familiar with the fact that Kw is equal to the concentration of H plus multiplied by the concentration of OH minus. So playing around with those figures and the fact that it reminded you of the ionic product of water being that value, you should have been able to calculate the concentration of H plus by inversely logging the pH being 11. Fed that then into the Kw equation by rearrangement to get the concentration of OH minus. So there are lots of things that can be asked in Unit 5, and it's not always as straightforward as you may think. So please, even though it isn't as highly percentage-wise content of your grade, it is really important that you prepare as thoroughly as you possibly can for that Unit 5 assessment in May, before your written exams in June, of course. Okay. There are more questions there for you, so please, as I said, feel free to go through them at your leisure. I've got the mark scheme after each question for you as well, so that you can check your own understanding. And if any of those aren't sitting well with you, that you don't quite understand it, then please either access the resources that I've outlined there, or simply go ask your teachers or your tutors in college. Okay. So any questions that remain can also obviously then also be asked to myself or Mr. Black when we have that session next week. So we've got the live session that's available for you to ask any questions that have crept up during the last few weeks of these sessions that you're not quite sure, that you want some clarity on, then please tune in and have those questions answered for you. But if, as just a reminder there, the final session was today. So the previous sessions there, if you've got any questions on any of those, so from Mr. Black's first session to this session today or any in between, then obviously we'll be available to answer those as thoroughly and as honestly as we can for you next week. So thank you for joining, and hopefully you'll all have found them useful, and certainly good luck to you in the summer.